You have in your math career come up with a whole bunch of different types of equations that you could not solve without using a graphing calculator. And we are now going to explore a method, a statistical method using a little bit of calculus, how to solve a function that you weren't algebraically allowed to solve. And it's an iterative process. So you make a guess, and using that guess, you refine the guess, and so on and so forth. And the more times you do the process, the more accurate your actual answer is going to be. So let's take a look at this function, and you know you have a root here, but you don't know what it is because you can't solve it algebraically. Let's call this the root a. So I'm going to start by making a guess, and I'm going to say my first guess is this point right here. So notice I'm way away from a. And what I'm going to do with this guess is I am going to use my guess to make a tangent line at that point. And then I'm going to follow that tangent line back to the x-axis, and that is going to be my guess number 2. So I'm going to call this x2. And notice how much closer my second guess is compared to my first guess. Have I actually hit the root? Not quite. So I'm going to do this again. I'm going to do this in a different color then. I'm going to do it in red. So I'm going to take my x2 point, and I'm going to find the equation, the tangent line of the curve, and I'm going to draw it in, and I'm going to follow it back and until it hits the x-axis, and then I'm going to call that my third guess. Now, is it exactly going to be right on A? No, but notice how much closer it's gotten. So with each time I apply the equation of the tangent line, I create a new guess that's closer and closer and closer to the root. And Isaac Newton is the first one that used this method, and hence it bears his name, called Newton's method. So this was sort of the general theory of it. We're going to do it with a specific example in the next slide.